So, can you give a whirlwind overview of the products that Come AI provides, like throughout its history and today?
I mean, yeah, the past ones aren't really that interesting. It's kind of just been refinement of the same idea. Uh, the real only product we sell today is the Comma 2.
Which is a piece of hardware with cameras.
So the Comma 2, I mean, you can think about it kind of like a person. And future hardware will probably be even more and more person-like. So it has, eyes, ears, a mouth, a brain, and a way to interface with the car.
Does it have consciousness? Just kidding. That was a trick question. Because
I don't have consciousness either.
Okay.
Me and the Comma 2 are the same.
You're the same.
I have a little more compute than it. It only has like the same compute as
Interesting.
a B.
You're more efficient energy-wise for the compute you're doing.
Far more efficient energy-wise. 20 petaflops, 20 watts, crazy.
But you lack consciousness.
Sure.
Do you fear death? You do. You want immortality. Of
course I fear death.
Does Come AI fear death? I don't think so.
Of course it does. It very much fears, it fears negative loss. Oh, yeah.
Okay, so Comma 2, when did that come out? That was a year ago? No, 2.
Early this year.
Wow, time. It feels like,
yeah.
2020 feels like it's taken 10 years to get to the end.
It's a long year.
It's a long year. So, what's the sexiest thing about Comma 2 feature-wise? So, I mean, maybe you can also linger on like what is it?
Yeah.
Like, what's its purpose? Because there's a hardware, there's a software component. You've mentioned the sensors, but also like what are its features and capabilities?
I think our slogan summarizes it well. Comma slogan is "Make driving chill."
I love it. Okay.
Yeah, I mean, it is. If you like cruise control, imagine cruise control, but much, much more.
So it can do adaptive cruise control things, which is like slow down for cars in front of it, maintain a certain speed, and it can also do lane keeping, so stay in the lane and do it better and better and better over time. It's very much machine learning based. So there's cameras, there's a driver facing camera too. What else is there? What am I thinking? So the hardware versus software. So Open Pilot versus the actual hardware of the device. Can you draw that distinction? What's one? What's the other?
I mean, the hardware is pretty much a cell phone with a few additions. A cell phone with a cooling system and with a car interface connected to it. And
by cell phone, you mean like Qualcomm Snapdragon?
Yeah, the current hardware is a Snapdragon 821. It has a Wi-Fi radio. It has an LTE radio. It has a screen. We use every part of the cell phone.
And then the interface with the car is specific to the car. So you keep supporting more and more cars.
Yeah, so the interface to the car, I mean, the device itself just has 4 CAN buses. It has 4 CAN interfaces on it that are connected through the USB port to the phone. And then, yeah, on those 4 CAN buses, you connect it to the car. And there's a little harness to do this. Cars are actually surprisingly similar.
So CAN is the protocol by which cars communicate. And then you're able to read stuff and write stuff to be able to control the car depending on the car. So what's the software side? What's Open Pilot?
So I mean, Open Pilot the hardware is pretty simple compared to Open Pilot. Open Pilot is, so you have a machine learning model, which it's in Open Pilot. It's a blob. It's just a blob of weights. It's not like people are like, oh, it's closed source. I'm like, well, it's a blob of weights. What do you expect?
It's primarily neural network based.
Open Pilot is all the software kind of around that neural network. That if you have a neural network that says, here's where you want to send the car, Open Pilot actually goes and executes all of that.
It cleans up the input to the neural network. It cleans up the output and executes on it. So it connects. It's the glue that connects everything together.
Runs the sensors, does a bunch of calibration for the neural network, deals with if the car is on a banked road, you have to counter steer against that. And the neural network can't necessarily know that by looking at the picture. So you do that with other sensors in Fusion and Localizer. OpenPilot also is responsible for sending the data up to our servers so we can learn from it, logging it, recording it, running the cameras, thermally managing the device, managing the disk space on the device, managing all the resources of the device.
So what, since we last spoke, I don't remember when, maybe a year ago, maybe a little bit longer, How has OpenPilot improved?
We did exactly what I promised you. I promised you that by the end of the year, you'd be able to remove the lanes. The lateral policy is now almost completely end-to-end. You can turn the lanes off and it will drive slightly worse on the highway if you turn the lanes off, but you can turn the lanes off and it will drive well, trained completely end-to-end on user data. And this year we hope to do the same for the longitudinal policy.
That's the interesting thing is you don't appear to be, maybe you can correct me, you don't appear to be doing lane detection or lane marking detection or kind of the segmentation task or any kind of object detection task. You're doing what's traditionally more called like end-to-end learning. So, and trained on actual behavior of drivers when they're driving the car manually.
And this is hard to do. It's not supervised learning.
Yeah, but so the nice thing is there's a lot of data, so it's hard and easy, right? It's
we have a lot of high quality data, yeah.
Like more than you need in a sense.
Right.
Well,
we have way more than we do. We have way more data than we need.
I mean, it's an interesting question actually, because in terms of amount, you have more than you need. But driving's full of edge cases. So how do you select the data you train on? I think this is an interesting open question. Like, what's the cleverest way to select data? That's the question Tesla is probably working on. The entirety of machine learning they don't seem to really care. They just kind of select data. But I feel like that if you want to create intelligent systems, you have to pick data well, right? And so do you have any hints, ideas of how to do it well?
So in some ways, that is the definition I like of reinforcement learning versus supervised learning. In supervised learning, the weights depend on the data, right? And this is obviously true, but in reinforcement learning, the data depends on the weights.
Yeah.
Right? And actually, both ways.
That's poetry.
So
that's brilliant.
How does it know what data to train on? Well, let it pick. We're not there yet, but that's the eventual.
So you're thinking this almost like a reinforcement learning framework.
We're going to do RL on the world. Every time a car makes a mistake, user disengages, we train on that and do RL on the world. Ship out a new model. That's an epoch, right?
And for now, you're not doing the Elon style promising that it's going to be fully autonomous. You really are sticking to level 2. And like it's supposed to be supervised.
Oh, it is definitely supposed to be supervised, and we enforce the fact that it's supervised. We look at our rate of improvement in disengagements. OpenPilot now has an unplanned disengagement about every 100 miles. This is up from 10 miles, like maybe a year ago. Yeah, so maybe we've seen 10x improvement in a year, but 100 miles is still a far cry from the 100,000 you're going to need. So you're going to somehow need to get 3 more 10x's in there.
And what's your intuition? You're basically hoping that there's exponential improvement baked into the cake somewhere.
Well, that's 10x improvement, that's already assuming exponential, right? There's definitely exponential improvement. And I think when Elon talks about exponential, like these systems are going to exponentially improve. Just exponential doesn't mean you're getting 100 gigahertz processors tomorrow, right? Like it's going to still take a while because the gap between even our best system and humans is still large.